Hello everyone, welcome back to my channel. Hello everyone, welcome back to Vyasa IAS CSAT course. Now we are starting the last chapter of the quantitative aptitude. That is about permutation and combination. Now, let me first give the introduction of permutation and combination, that how actually you have to do these chapters. So whenever you are doing the chapter of permutation and combination, the first and foremost thing that we have to consider here is that it is very intuitive in nature. Permutation and combination chapter is very intuitive in nature. That is, you see a problem, you have to think about the problem, or you have to visualize about the problem. Okay, and whatever mathematical solution you are giving, you have to be very confident with that. Okay, because see, permutation and combinations are a certain kind of conditions. Okay, are a certain kind of conditions. It is that a group of people are given, you have to select somebody, or you have to like put them in some place, but you have to find in how many ways you have to do, in how many ways can you do these things. Okay, so I hope you will be able to understand this thing, that what permutation and combination actually mean is that if a group of people or a group of something is given to us, and in how many ways can we select them or we can arrange them. So that is actually the matter of permutation and combination. Okay, so this is very mathematical in nature, but at the same time you have to be very keen about whatever you are reading in your sentence statement, so that you are able to do the questions very well. Okay, so try to understand each and every conditions well, so that you don't have to like memorize it. Do revise this PDF which I am giving you, because I am including all kinds of notes in here. So do revise this PDF many times, but at the same time do not try to mug up things, try to understand things. Try to watch this video again and again if you don't understand it, or you can ask me in your a doubt group also, that how to solve these questions. Now let us begin with this. Now before bringing the chapter of permutation and combination, we have to understand what is factorial. So for example, if I am writing n factorial, n is what? Any number from 0 to 1. Okay, sorry, from 0 to infinity, any natural number. Okay, so when we are writing n factorial is actually equal to how much? N minus 1, and we'll keep on multiplying the consecutive numbers until 1 comes. So for example, 4 factorial is given. So that means 4 into 3 into 2 into 1. For example, 8 factorial is given. That means 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay, so I hope this is very simple. Understand this thing, that factorial n means the product of n consecutive numbers starting from n till the number 1 comes. Okay, so 6 factorial is obviously 6 into 5 into 4 into 3 into 2 into 1. Okay, so this is how we do these things. Now let us move forward. Understand this thing, 0 factorial is always equal to 1, and only factors of natural numbers are defined. Okay, and factorial is defined only for n greater than or equal to 0. We don't have factorial for negative numbers. Okay, so now we have understood the factorial. So let us understand what combination means. Okay, so when we are writing NCR, okay, NCR, so what NCR actually means is that the number of ways in which R things at a time can be selected from among n things available. So for example, you have 4 people and you have to select one person. Okay, you have 4 people or 4 persons and you have to select one person. So how will you do that? 4C1 ways you can do that. Okay, 4C1 means what? See, out of 4 person, if you have to select one person, then how many ways you can do that? Four ways. Okay, either you will select, let's say these 4 person are A, B, C, and D. Okay, so out of this, if you have to select one person, you can do in 4 ways. Either select A or select B or select C or select D. But if you have to select 2 persons, okay, if you have to select A, B, C, D is given, okay, if you have to select 2 persons, okay, So we can do in 4C2 ways, I am saying. Now, what is four? How many ways actually you can do that? Either you can select this AB, or you can select this BC, or you can select this CD, or you can select this AC, or you can select this BD. Is there any other way? Yes, there is one more way, or you can select this AD. Okay, or you can select this AD. Fine. So this thing you can do in how many ways? 4C2 ways. And what is 4C2? Okay, what is 4C2? See, actually, when we mean that I am saying NCR, okay, then actually NCR is given by factorial n divided by factorial r into fact, n minus r factorial. Okay, so this is how we do it, and that will also give you same. See, we got six types of ways in which we can select two people out of these four people. Okay, now let us see if I am saying NCR is equals to factorial n divided by factorial r and n minus r factorial. So what will come? So I have factorial 4 and then I have this r. So I have factorial 2 and then I have this n minus r. So again 4 minus 2. So I have what? Factorial 4 divided by factorial 2 divided by factorial 2. And what is factorial 4? 4 into 3 into 2 into 1. And what is factorial 2? 2 into 1. And what is factorial 2? 2 into 1. So this 4 gets cancelled. You get equal to 6. And that is only we find out here. Okay. So actually now you have like, you had only 4 people and you had to select 2 people. So you were able to do this thing very easily by counting. But if you have like a very large number, so you won't be able to make the combination every time. So you do in this way. Okay. So you do in this way. What? You use this formula NCR is equals to factorial n divided by factorial r, n minus r factorial. Okay, n minus r factorial. So this is how we do these kind of question. Once again, understand what I am meaning here when I am saying we have to select. Okay, so we are given four people. Four people are what? A, B, C, D, and you have to select two people out of them. You have to select two people out of them. So in how many ways you can do this? You can do this in six ways. Okay, A, B, B, C, C, D, okay, A, C, B, D, and A, D. Okay, now I am saying that these two people have to be put in two homes, and these homes have different identity X and Y. In how many ways you can put these two people in these two homes? Okay, so I can either put A here, I can either put B here. Okay, or I can put B here, or I can put A here, or I can put B here, I can put C here, or I can put C here, I can put B here. Okay, or I can put C here and D here, or D here and C here. Okay, or I can put uh, A here, or C here, or C here, or A here, or I can put uh, B here, or D here, or D here, or B here. Okay, or I can put A here, or D here, or D here, or A here. Okay, so this is what I am saying. I am doing permutation. When I am doing permutation, actually what I am doing, I am arranging. Okay, because here what I am doing, I have given two homes X and Y, or let us say with address X and address Y, and I have to put two people here. So what I am doing, I am trying to arrange these two people. When I am trying to select these, when I am trying to do the selection process, that I have to select two people out of these four people, what I am doing is basically I am trying to do the combinations. So for that I use NCR formula. But when I am doing permutations, I will use NPR formula. So what is NPR? NPR is factorial n divided by factorial n minus r. Okay, so whenever I am saying NPR, so NPR means factorial n divided by factorial n minus r. Okay, so when I am saying this, so I have four people and I have to arrange this in two ways. So how will I do? 4PR, so which is factorial 4 divided by factorial 2. Okay, because 4 minus 2 is 2 only. So I get how much? 4 into 3 into 2 into 1, and then 2 into 1. So I am able to do this in 12 ways. This is what I got: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So I am able to do this thing in 12 ways. Okay. So this is how we do these kind of question. I hope now everybody understand what is the meaning of permutation and what is the meaning of combination. Okay, I hope now you are okay with this term. Now, see, I am saying the keyword here is selection. Okay, so please understand that when we are saying, I am saying A, B, C, D. Okay, so when I am saying that I have to select, let's say 3% out of these. So either I select A, B, C or B, C, D or A, C, D, whatever. So here order makes no importance. Okay, so when I'm just trying to select people, then order makes no importance. But when I'm doing permutation, okay, for example, I am trying to select these A, B, C, D, and I'm trying to select three people out of them, and I'm trying to put them in three houses. So I can put either A, B, C here, or I can put A, C, B here, okay, or I can put BSc here, okay. So there are number of ways which we can do this. Okay, I am trying to, first what I am doing in permutation, first I am trying to select three people. So I first selected ABC, okay, then I got what, then I can arrange these ABC in how many ways, ABC, ACB, or BAC. Is there any other way? Yes, there is one more way. Okay, so I can CAB or CBA also. Okay, CAB or CBA also, or BCA also. Okay, so number of ways. See, when I am trying to select people from here, three people from here at one instance. Okay, so I can select like ABC, BCD, or ACD, or ABD. Okay, so I can do this in four ways only. You can check this by formula also. When I'm trying to select four people from A, B, C, D, how I can do it? 4C3. Okay, so 4C3 is what? Factorial 4 divided by factorial 3 and factorial 1. So that means 4 into 3 into 2 into 1. Okay, or we can write factorial 4 as 4 into factorial 3. So when I am doing this as 4 into factorial 3, so basically this 3 and 3 gets cancelled and we get 4 as our number. Okay, but when I am trying to do the permutations, okay, when I am trying to do the permutation, okay, so if I am selecting these three people A, B, C only, so then you see we have six kind of arrangement. Okay, and if I will select B, C, D, then I will have another six arrangement. Okay, and if I will select A, C, D, then I will have another six arrangement. Okay, and if I will select ABD, then I will have another six arrangements. So basically 6 into 4. So I'll get 24. Let us check whether we get 24 or not. So what is it? NPR means we can do this in NPR ways. So out of four people, I have to arrange three people at three places. Okay. So how can I do this? 4P3, and what is NPR? What is NPR? Factorial n divided by factorial n minus r. So factorial 4 is 4 and factorial n minus r is 4 minus 3. So factorial 4. So 4 into 3 into 2 into 1. So that is equal to 24. Okay. So this we can do in four ways. Okay, this we can do in four ways. This we can do in 24 ways. I uh, I explained it to you already. So be very clear with what permutation means and what combination means. Okay. I hope up till now it is now very clear. Okay, so we already know NCR is equals to number of combination of n things taken r at a time, and NCR is equals to what? Factorial n divided by factorial n and sorry factorial r into factorial n minus r. Okay, so NCR is equal to what? Factorial n divided by factorial r and multiplied by factorial n minus r. So be very clear with this thing. Now let us move forward. Okay, let us move forward. Now look at this. Some typical situation in which selection or combinations are used. Okay, selection of people for a team of or a party, a job, an office. Okay, so for example, if there are 16 members and we have to select 11 members out of them for a cricket team. So how will you select 16? See 11 ways. Okay, but if you have to like arrange people, okay, if you have to arrange people, है ना, that someone will come at first, someone will be the vice captain, someone will be the captain. Okay, then in that case you will use what? You will use permutations. Okay, Now, see, the situations here we are talking about the situation in which selection and combination is used. Okay, so selection of a set of objects like letters, hat, points, pants, shirts from amongst another set available for the selection. So in that case, we use selection. Okay, in that case, we use selection. Now, see, already I have explained to you what permutation is. Okay. So, in permutation, we are doing both the things. We are selecting also and arranging also. Okay. So, for example, if it is said that we have four people A, B, C, D, and we have to put them in four places. One, two, three, four places. Okay. So, if we have to arrange them in like this X, Y, Z, and let's say L places, so in how many ways we can arrange four people in four places? We will directly write factorial for y, because we know NPR is equals to what? Factorial n divided by factorial r n minus r. Okay, so this will become factorial for what will be r here? R will be how much? Um, so we have to put them in four places. So factorial 4, and what is n minus r? 4 minus 4. Okay. So that will be 0. So you will have factorial 4 and factorial 4. Okay. But sorry. See, if I am saying to you that we have four persons A, B, C, D, and we have to put them in four places, let's say X, Y, Z, and L. Okay. Now I am saying you have to arrange these four people in these four places. So how will you do that? Okay. How will you do this thing? See, we can do this in, it's very easy. I will simply say we can do this in factorial four ways. But how we can do it this in factorial four ways? Let us understand this thing. See, we already know the formula. What is the formula of NPR? NPR is equals to factorial n divided by factorial n minus r. Okay. So that is what factorial 4 divided by 4 minus 4 factorial. That is factorial 4 divided by factorial 0, which is factorial 4 only. Okay, which is factorial 4 only. So this is how we can do this. Okay, this is how we can do this. So so permutation means ordered selection. Okay, in permutation we are trying to select also, and then we are trying to arrange also. Okay, so when I am saying this thing, that in how many ways you can select four people out of four people? One way, because you are selecting every one of them. Okay, there is only one way to do that. But then in how many ways you can arrange? So you already know you are given A, B, C, D. So you will put A here, A here, A here, then put B here, then exchange this DC. Okay, then you can do what? Bring C here, bring B here, bring D here, and so on. So that way you will get how many ways? 24 ways to do these things. Okay, 24 ways to do these things. I hope I am able to make sense to you all. Okay, so permutation is ordered selection or ordered or arrangement. Okay, permutation is what? Arrangement. So whenever you see the word arrangement, okay, in that question, please always lit your brain bulb that, oh, this is asking about permutation, because no question will directly say to you that permutate this or combine or tell me the selection. Okay, so whenever you see the word arrangement, or you read the question and see the meaning that it is asking about the arrangement, then what you have to do actually is you have to apply the permutation. Okay, I hope this is very clear to all of you. Okay, so this is all. Now let's move on to our next concept. Okay, so see, what are the situations in which we use permutation? Okay, so we use permutation making words and numbers from a set of letters or digit available. Okay, so for example, you are given 5 digits and you have to make a 3 digit number. Okay, and you have to make a 3 digit number. Okay, so in how many ways you can do this if no digit is repeating? Okay, if no digit is repeating, you are given this 4, 3, 2, 1. Okay, and if no digit is repeating, in how many ways we can do this? Because select um, uh, let's say 6, select 3 number out of these and then make the number. Okay, and then if no digit is repeating, so obviously we can do it 4pr ways. Okay, 4p, sorry, 5p 3 ways. Okay, because npr ways we can do this, so 5p 3 ways we can do this. Okay, so if no digit is repeating. Okay, so making words and numbers from a set of available digit. And see, if the digits are repeating, see, I especially mentioned, look at this question. I'm saying we are given five numbers. Okay, we are given five numbers. Okay, let's say those numbers are 4, 3, 2, 1, 8. Okay, and we have to make a three digit number. So my first question is, you have to make a three digit number from any of these five numbers such that no digit is repeating. Okay, so what you will do actually, first you will select three number. First you will select three number out of these five number. So how many ways you can do that? 5c, three ways. Okay, and when you have selected these three number out of these five numbers, so how many ways you can arrange them into factorial three ways? Because I told you, when you have already selected three things, so in how many ways you can exchange these places? Factorial three ways. Okay, factorial three ways, I already told you. So you know 5c3 is what? 5 factorial 5 factorial 3 and factorial 2, and then you have this factorial 3. So factorial 3 and 3 will get cancelled, you will get 5 into 4 into 3. Okay, so that means we have 60 numbers. Okay, we will have 60 numbers if we'll select any five from these five numbers, and we are not repeating any digits. Okay, we are not repeating any digits. But if I ask you that you can repeat any number of digits, okay, there is no restriction on that, then how many numbers will be formed? Okay, so see, you have this 43218. You can repeat any number of digits. So this place can be filled in how many ways? Five ways. Okay, this place can be filled in how many ways? Five ways. There is no restriction. And this place can also be filled in five ways. So when there is no restriction on repeating and non-repeating, you can do, you can, from five numbers you can make 125 three digit numbers. Okay, from these five numbers you can make 125 digit numbers. But let us say if zero was here now, so then you would not place zero here. Okay, because then it won't be a three digit number. So you can do this in four ways. Okay, let's say we remove 8 from here and we put 0 here, and then you can do this in 5 and 5 ways. So this will become what? 25 into 4, that is in 100 ways we can do this. Okay, that is in 100 ways we can do this. So I hope you are able to understand what I am saying. How do we do these kind of questions? Okay, there is no restriction here. Now see, this question can be very handy if we have to find even numbers. Okay, so for example, if anybody is asking you that you are given these digits 4, 3, 2, 8, and let us say 9. Okay, these are five digits, and somebody asks you how many even digit numbers, how many even numbers can be formed out of these number. Okay, a three digit number. Okay, you are given this five number and I'm asking you that how many three digit even number can be formed out of these number. Okay, no restriction on anything. You want to repeat, not repeat, there is no restriction on anything. Okay, so now see, for even number we know that our unit place should be even number. Okay, so we'll do what? 2 and 8 we'll fix here, that we can do, we can put only we can put this sorry, we can fill this last place only with two numbers, that is two, no, we have three numbers here. Okay, we have three even numbers here, so we can only do this thing in three ways. We can only put we can only fill this unit digit in three ways. Rest other what? 1 2 3 4 5 we have, so we can do this in five ways. We can do this in five ways. So we, you can do this in how many ways? 75 ways. Okay, you can do this in 75 ways. So this is how you can apply with even number. See, now we don't have many cases where only by arrangement we can tell that, okay, this is a odd number or any number that is divisible by this. So this is very much handy when you want to find the even number out of the out of the numbers given to you. Okay, so I hope you understand this thing very well. So this is how we can find numbers from a set of numbers available. Okay, if we have to find words, okay, if we have to find, for example, you are being given, let's say, cat. Okay, so how many words with or without meaning we can form, we can form from this cat word? Okay, so you just have to arrange, these are three places, you have three words. Okay, you just have to make the arrangement. Okay, so that will be factorial 3, that is six number, six words you can form. You can Either it can be ACT, okay, or it can be ATC, or it can be CAT, or it can be CTA, or it can be TAC, or it can be TCA, okay, with or without meaning. Okay, so you can do it in this way. Now I'm saying you have this number. Let's say we are saying look. Okay, so how many words with or without meaning can be formed with the letters of the word look? Okay, so when we are doing these kind of question, so actually these two words are same. Okay, actually these two words are same. So let us, if I am saying look, okay, so if I am putting O here and O here and OLK here, that is one word. If I exchange these two, then also this will be an identical word only. Okay, if I put this over here and I put this over here, then also it will be identical word only. Okay, so what I will do, uh, if I am given some word in which two words are repeating, okay, if I am given some word in which two words are repeating, sorry, two, if I am given some word in which two letters are repeating, if I am given some word in which two letters are repeating, what I am going to do, see, four words are being given to me and four places are there to be arranged. I can do this in factorial four ways. Okay, I can do this in factorial four ways, but these two words are identical, so I'll put factorial 2 here. Okay, so then how many ways I'll get this in 12 ways. Okay, so I hope everybody is clear with this thing. Okay, so and another is filling post with people. Okay, so for example, if I am given 9 people and I have to make one person president, one person vice president. Okay, so in how many ways I can do this? See, if I was asked that I have been given 9 people and I have to select 2 people out of them, so that I can do in NC2 way, 9C2 ways. Okay, so 9C2 is what? Factorial 9 divided by factorial 2 divided by factorial 7. Okay, factorial 9 divided by factorial 2 divided by factorial 7, because n minus r, because NCR is equals to n factorial divided by r factorial and n minus r factorial. Okay, so this is the thing. So I have what? 9 into 8 and 2 into factorial 7, and here factorial 7, so this and this will get cancelled. You can select 2 people out of 9 people in 36 ways, but now I have to select 2 people and I have to give one person the post of president, one person the post of vice president. So any 2 people I am selecting, any 2 people I am selecting. So let's say these 9 person are A, B, C, D, E, F, G, H, I. Okay, are these 9 people? Yes. So if I am selecting, let's say A and B, so I have selected them, but then I can either make A president or B vice president, or B president or A vice president. Okay, so that means for each case I am selecting 2 cases are there. So that means I can do this in 72 ways. Okay, I can do this in 72 ways. Okay, now see, this is similar. Here we can use the formula also. NPR, what is N9 here? What is P? P here 2 is R here. So you can do this in factorial 9 divided by factorial 7 ways, because NPR is equals to factorial N divided by factorial N minus R. So this becomes 9 into 8 into 7 factorial, and this becomes 7 factorial, this becomes 72. That's all. Okay. So this is how you do these kind of questions. I hope I'm able to explain to you. Selection of a batting order of a cricket team of 11 from 16 members. Okay. So that is only what I was telling you, that you can select 11 members out of 16 members in 16C11 ways. So that will be 6 factorial 16 divided by factorial 11, and 16 minus 11, that is factorial 5. Okay, so you will have factorial 16 into 15 into 14 into 13 into 12. Okay, and this 11 and 11, and that also now you will divide by factorial 5. Okay, so 16C11 you can do this in these many ways. But when you are asked to make a batting arrangement, okay, so either you can put one people person here, and so you have, so in that you will multiply this by factorial 11 as well. Okay, in that you will multiply this by factorial 11, because each person can be arranged in 11 ways. Okay, so factorial 11 you will write. Okay, factorial 11 you will write. So this is how you do these kind of questions. Now putting distinct object in distinct places, putting letters in envelope, finishing in horse race. So all these things. We'll see the questions when they will come. Okay. Um, See, I already explained to you all these examples very well. You can now read them. Now, let us move forward. What is the relationship between permutation and combination? See, I already told you what is the relationship between permutation and combination. Try to understand this thing. When I was telling you about the example that uh, there are two posts, one of president and one of vice president, and there are nine people, and you have to select nine people out of these two, and they can be given any position. We don't want to know who is given president and who is given vice president. So that is actually we are using combination that out of nine people we are selecting two people and we are putting them either as president or vice president. We have to select two people only, that is our consideration. President and vice president who will become, we don't know anything about it. So that can be done in 36 ways. Okay, but if particularly I have to put one as president and one as a vice president and I am concerned about that, so there are two positions, and I have done, and then I can select two people out of nine people in 36 ways. So I can arrange or I can give them to particular post of president and vice president in 36 into factorial two ways. Okay, so that means I can do this in how many ways? I can do this in 72 ways. Okay, so what I am actually saying that your NCR into factorial R gives your NPR. Okay, and that is only the formula, because factorial n divided by factorial r and n minus r is permutation. You multiply r factorial, so this will become factorial n divided by factorial n minus r, which is nothing but NPR. Okay, which is nothing but NPR. See, try to understand this thing in the form of a statement, okay, and in the form of this as well. So I'm telling you, read your maths, okay, and uh, you can use maths, and you can, like, whenever you are reading some statement, try to convert them into some mathematical format, and whenever you are reading some mathematical thing now, so try to convert them into statement. This is how you develop the more understanding, and this is how you make your brain work. Okay, I'm telling you the method of how to put your brain into your work. Okay, so this is how we can do this now. Okay, fine. So this is how we can do this. Now the permutation or arrangement of R things out of n is nothing but the selection of R things out of n followed by the arrangement of the R selected things among themselves. Okay, so let us do that. See, I already explained to you this statement. Okay, what is permutation? Permutation is selection plus arrangement. Okay, and what is combination? Combination is just selection. Okay, so once I have done the combination, okay, so whenever I'm arranging this, so that becomes permutation only. Okay, that becomes permutation only. There is one more relationship given. One more relationship is given. What? See, NPR is equals to NCR into RPR. Okay, what is RPR? What is RPR? RPR is actually factorial R only. Okay, when we are saying RPR, that is 4P4. So that means what? Factorial 4 divided by factorial 4 minus 4, and we know 0 factorial is equals to 1, so that means factorial 4. So whenever, see, factorial R is nothing but RPR. Okay, so that is this notation given. Okay, so keep in mind this also. See, once again try to clear this. NPR is equals to NCR into factorial R, because I already told you with the help of the formula. Now this factorial R can be written as RPR also. Okay, this is nothing but that only. Okay, so I hope everybody is clear with this thing. See, if you think I am going fast anywhere, this is all obviously recording. You can go back and listen. Okay. Now see, this is MNP rule. So this is no rule. See, whenever I am saying this is that rule or this rule, so maybe it becomes a very much burden for you to remember so much. Although you can remember it, those who are good with the memory, they can remember it. But if you don't know how to remember things, okay, so then try to understand things. So see, if there are three things to do, and there are m ways of doing the first thing, and n ways of doing the first second thing, and p ways of doing the third thing, then there will be m cross n cross p ways of doing all three things together. The works are mutually inclusive. Okay. So whatever this statement is saying, I think that looks very cumbersome to you. But what I am saying is the same thing I told you when I am saying that I have been given five letters. Let's say I'm given M, N, L, O, P. Okay. I have been given five letters and I have to make a three letter word out of this five letter. So in how many ways I can do that? First, I will do what? I will select and then I will arrange. So in 5C two ways I can select three letters out. Sorry, 5C three ways I can select three letters out of five letters, and in factorial three ways I can arrange them. Okay, in factorial three ways I can arrange them. Or what I can do, I can directly do 5P3. So in this I am already selecting also and I am arranging also. Okay, so this is the way of doing things. Now see, when you are given, when I am talking about this M and P rule, okay. So when, if you are saying without repetition, okay. So I have been given these three words. I have been given this three-letter word. Now you can repeat any word n number of times. Okay, you can repeat any word. So you are given, let's say we have to fill M word here, N word here, and P word here. Okay, so you can do this in three ways. You can do this in three ways, and you can do this in three ways. You can either put M here, N here, or P here. You can either put M here, N here, or P here, or you can either put M here, N here, or P here. So you can fill all these things in three ways, and you have no restriction of anything. So you can do this in 27 ways. Okay, you can do this in 27 ways. So this is how we do these kind of questions. Now see, the number 1, 2, 3, 4, 5 are to be used in forming a three-digit number without repetition. So in how many ways we can do this? So now you can't repeat. See, understand this question, you can't repeat. So you are given 1, 2, 3, 4, 5, and we are given three places. Okay. So for example, I am filling this first place. So I can choose any number out of them. Okay, I can choose any number means how many ways I can fill this place? Five ways. Why? Because I have the option of five digits. Okay, I have the option of five digits, so I can do this in five ways. Now what? Whatever digit I have chosen for here, I can't use this digit here because it is saying without repetition. I can't repeat. So I can do this in four ways because four digit are left. Any four digit, I don't know which one digit. Okay, whichever digit is used here, I can't use that digit here. Only that is the problem. Okay, so I can do this in four ways. Now I have used two digit here, I can't repeat those two digit here. Okay, so how many digits I am left with? Only three digit. So I can do this in three ways. So I can do this in how many ways? 5 into 4 into 3. So that means 20 into 3. So that means how many ways? 60 ways I can do this. So are you clear with this thing? No, this is very simple. See, what I am saying here is the number 1, 2, 3, 4, 5 are given. Okay. And they are saying they are to be used for forming three-digit number without repetition. Okay. So 1, 2, 3, 4, 5 are how many number? Five numbers. Okay. I have to form a three-digit number. So first digit, this digit or digit, anyone you can take. I can use all the five numbers because no restriction here, but whichever number I have used here, I can't use here. So I can do this only in four ways. Now I have used two numbers. Okay, I have used two numbers. Only one number. How many numbers are left? Three numbers are left. So I can do this in 5 into 4 into 3 ways. So this is what the question is saying. If there are three things to do and there are m ways of doing the first thing, n ways of doing the second thing, and p ways of doing the third thing, so then you can do this in m cross n cross p where, and the works are mutually inclusive. Okay, the works are mutually inclusive. So this is what the question means in that. Okay, and see, it is saying when the pieces of work are mutually exclusive, there are m plus n plus P ways of doing the complete work. Okay, so see, let us see what are the example of these kinds of questions. Okay, fine. So, when it is saying that when the pieces of work are mutually exclusive, okay. So, see what is happening here is they are saying that the pieces of work are mutually exclusive. So, the number of ways of doing is that m plus n plus p. Okay, m plus n plus p. Okay. So, what is being said here that you are given, let's say, four numbers. So you can only fill, you are given that this place can only be filled by, let's say A, B, C, D. This place can only be filled by E, F, G. Okay. And this place can only be filled by what? This place can only be filled by, let us say, X and Y. Okay. This place can only be filled by X and Y. So in how many ways you can do this? Four ways. Okay. In how many ways you can do this? Three ways. In how many ways you can do this? Two ways. Okay. But your answer will be how much? The total number of ways in which this can be done is 4 into 3 into 2. Okay. 4 into 3 into 2. Okay. Fine. Uh, Now let us look at this thing. The number of permutation or arrangement of n different things taken all at a time. Okay. So that is the same thing when I am saying that you are given four people and you have to put them in four homes. Okay. So that is the same thing when they are saying number of permutations or arrangement of n different things taken all at a time. So four people are given to us and we have to arrange those four people. So that we can do in how many ways? Factorial four ways. 11 cricket players are given to us and in what position the batting order is decided. So we can do this in how many ways? Factorial 11 ways. Okay. How many ways? Factorial 11 ways, because we are given no restriction. Okay. So that is the same thing they are saying when number of permutation of n different things taken all at a time they are saying. Okay. Now let us look at this question. Sorry, this concept. Number of permutation of n things out of which p1 are alike and are of one type, and p2 are alike and are of second type, and p3 are alike and are of third type, and the rest are all different. That is factorial n, है ना? Divided by P1, P2, P3. Okay. So, like, for example, you are given these 10 boxes. Okay. 10 boxes. And you have 5 red balls. Okay. 3 blue balls and 2 green balls. Okay. You have this 10 boxes and they are being numbered 1, 2, 3, 4 till 10. Okay. You have 10 boxes and they are being numbered 1, 2, 3, 4 till 10. Okay. So if I am asking the number of ways in which you can arrange 5 red balls, 3 blue balls, and 2 green balls in them, will be given by what? Okay. So for example, if I am putting a red ball here and red ball here and red ball here, now if you put this red ball here and this red ball here and this red ball here, they are the same arrangement. So if I am saying that this 10 balls, these are 10 balls, 5 red balls, 3 blue balls, and 2 green balls. These are 10 red, 10 balls. They can be arranged in factorial 10 ways. So that is not correct because 5 red balls are identical to each other. three blue balls are identical to each other, two green balls are identical to each other. So to eliminate the represent repetition, what I will do, I will divide this by factorial 5 because 5 red balls are identical. I will divide this by factorial 3 because 3 blue balls are identical, and I will divide this by factorial 2 because 2 green balls are identical. So I hope you understanding this thing. So the answer will come what? Factorial 10 divided by factorial 5 into factorial 3 and factorial 2. So that is given by what? Obviously, now you can do this 10 into 9 into 8 into 7 into 6 into factorial 5. So factorial 5 will get eliminated. This is actually what? This is 6 into 2. Okay, so 6 also will get eliminated. This will become 4, and now you can obviously solve this. Okay, similarly, see, it is asking the number of words formed with the letters of the word Allahabad. So how many places are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places are there. Okay, so with the given words, factorial 9 arrangement can be made, but how many of them are alike? This A is repeated 4 times, so 4 are identical, so divide by factorial 4. And this L is repeated 2 times, so divide by factorial 2. This H is also repeated 2 times, so divide by factorial 2. So this is the number of words that can be made from the letter of the word Allahabad, and then you can find this out. Okay, so I hope you are also very clear with this concept as well. Okay, now it is saying the number of permutation of n different things taken r times when repetition is allowed. Okay, so I already told you this. See, this is actually the same case when I am saying that uh, you are given 43215. Okay, now you have to form a 3-digit number, and in that you can select any one of the digit and repetition is allowed. So that can be done in n to the power r ways. Okay, so for example, see, when I am saying these are the 5 numbers and you have to find a three digit number, and you can allow the repetition. So I can fill this place in how many ways? 5 ways. I can fill this place in how many ways? 5 ways. And I can fill this place in 5 ways. So that will become 5 into 5 into 5. So that is 5 ka cube. So actually what it is saying, number of permutation of n different things. Okay, n different things. So how many things are there? N different things. Okay, taken r at a time. So we are taking how many? R at a time when repetition is allowed. So that can be done in 5 to the power 3 ways. Okay, so any number you have to find a 4 digit number out of mm, there are 10 different digits. Okay, 4 digit number out of 10 different digit. Okay, so the only restriction here is that you can't put 0 at the beginning. Okay, and otherwise, so this can be done in 9 ways. Rest, this can be done in how many ways? Okay, this can be done in 10 ways, this can be done in 10 ways, and this can be done in 10 ways. So 10 cube into 9. Okay, because there is restriction here, just put 9 here, and otherwise 10 n to the power r ways. So I hope you understand what this case is saying. Number of permutation of n different things. We have n different things, and we have to take r at a time, and repetition is allowed. Okay, repetition is allowed. So that can be done in n to the power r ways. See, we are going to see a lot of questions. We will give 3 classes of permutation and combination. In this classes I'm trying to explain all the concepts here, and then I'll try to have multiple questions. Okay, so that permutation and combination, after this 4 hours you don't have to like spend more hour in learning things. You can just solve your mock test and everything, and that will be okay for you. Okay, so this is what we aim here. Now in, look at this, in how many ways 4 rings worn in the index, ring finger and middle finger, if there is no restriction on the of the number of rings to be worn on any finger. Okay, see what it is actually saying that let's say we have they are asking about 3 fingers. Okay, we have index finger, we have a ring finger, we have middle finger. Okay, so in how many ways 4 rings can be worn in the index, ring and middle finger if there is no restriction of the number of rings to be worn on any finger? Okay, so see, in this index finger, how many rings we can put? 4 rings we can put. Okay, so then there will be no rings here and here. Okay, then we can put 4 rings here as well. Okay, and we can put four rings here as well. Okay, or we can do what? 4 3 2. Oh, four ring. So sorry, not 4 3 2. 1 1 2. Okay, 0 1 3. Okay, 1 0 3. So many ways are there. Okay, so what it is actually saying, in how many ways four rings can be worn in the index ring and middle finger. So this is the same as number of permutation of n things taken r at a time. Okay, taken r at a time, but there is no restriction. Okay, there is no restriction that which ring has to be um, um, there is no restriction in which ring has to be worn in which finger. Okay, so obviously, how many things, how many places are there? Three. Okay, and how many rings you can take at a time? Four. Okay, so that is given by how n to the power r. See, you can select out of four rings, you can select any three ring. Okay, any three ring, and you can wear, and one ring will be left out. Okay, so you have to understand here how many places are to be filled, how many arrangements have to be made. Okay, see, in the earlier question, if you see, okay, when we were asking about this, so number of permutation of n different things taken are at a time when repetition is allowed. Okay, when repetition is allowed. So see, basically you have this four rings. Okay, you have this four rings, and you can put each ring in how many places? Three places. Okay, each ring in how many places? You can put three places. You have this four rings, you can put each ring in three places. So how will you put? Three, 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 and three. Okay, so uh, that will be 3 to the power 4. Okay, that will be 3 to the power 4. So this is how you do this. Understand this thing once more. See what I am saying, in how many ways four rings can be worn in the index ring and middle finger. So what is n here? N is equal to 4. Okay, n is equal, sorry, um, see, look at this question. It is saying, in how many ways four rings can be worn in the index ring and middle finger if there is no restriction on the number of rings to be worn on any finger. Okay. So we are basically saying there is no restriction of number of rings to be any finger. So there are four rings, है ना? And each ring can be put in how many places? Three places. Okay. So you are having this one ring. You can put this ring in three places. You are having another ring, you can put that ring in three places. You are having another ring, you can put that ring in three places. You are having fourth ring, you can put that ring in three places. So how many total places are there? 3 to the power 4. Okay, this is how you do these kind of question. I hope this is becoming clear to you. Okay, so this is how we can do. Now let's move on to our next concept. See, what is the next concept? It is saying number of selection of R thing out of n identical things. Okay, is equals to 1. So n things are identical, and it is saying in how many ways you can select 5 marbles can be chosen out of 100 identical marbles. So 100 identical marbles are there. You have to choose 5. You can choose in one way. If you have to choose, like let's say 6 marble, that also can be done in one way only. And if you have to choose 10 marble, that also one way. And if you have to choose 100 marble, that also in one way. Okay, so number of selection of r identical things out of n identical things is equals to 1. Okay, see, in that case, if all the rings were identical, okay, if all the rings were identical, then in one way, then no, if, because fingers are not identical, so okay, fine. Fine. Now see, total number of selections of zero or more things out of k identical things. Okay. See, in the earlier case, we are saying total number of selection of uh, are things. Okay. The statement earlier was total number of selection of are things out of n identical thing is equals to 1. Okay, here we have not included the case where we can select 0 marbles. If I can select 0 marble, then in how many ways I can do it? So that thing only we are saying. Okay, that thing we are saying number of total number of selection of 0 or more things out of k identical things. Okay, so see, if I am having n identical things, okay, if I am having n identical things, So in how many ways I can select zero or more things? Okay, in how many ways I can select zero or more things? So see, I have n identical thing. If I am selecting zero things, then in zero ways. If I am selecting one thing, then one, two, three, four, five, and so on. Okay. See, try to understand this thing. Let us say I have five rings. Okay. And somebody asked me, how can I select zero or more rings from here? So I will say six ways. Why? Either I can select zero ring, or I can select one ring, I can select two ring, three ring, four ring, five ring. Okay, and I'm saying these five rings are identical. Okay, I'm saying this five rings are identical. Somebody asked me how many ways you can select zero or uh, more rings. Okay, in how many ways you can buy zero or more rings? So I will say six. Six ways. Why? Because either I will select zero ring, one ring, two ring, three ring, four ring, five ring. Okay, so I hope this is becoming clear to you. Okay. So total number of selections of zero or more things out of k identical things is equals to k plus 1. This includes the case where we are selecting zero articles. Okay, this includes the case where we are selecting zero articles. Now look at this. We have total number of selections of zero or more things out of n different things. Okay, now n different things are there. None of them are identical. In how many ways we can select zero or more thing? Okay, so you have, like, let's say you have one pen, one pencil, one book, one rubber. Okay, now I am saying in how many ways you can select zero or more things from them. Okay, so how many ways there are? How many things? Okay, there are four things. So either you can select one pencil, one pen, one rubber, or one book. Okay, so 4C one ways. If I am selecting pen out of these four, so I can do this in 4C one way. Okay. So, if I am selecting like zero items from them, so I can do in 4C zero ways. If I am selecting two items from here, I can do this in 4C two ways. If I am selecting three items from here, I can do this in 4C three ways. If I am selecting four items from here, I can do this in 4C four ways. So basically what this statement means is that total number of selection of zero or more thing out of n different things. So I am saying that don't select any of these items: pen, pencil, rubber, book. Okay, or select one pen and one pen and one book. Okay, or I am saying select one rubber and one book. Okay, so that means when I'm selecting none of the thing, I am doing this in 4C0 ways. These are n different things, four different things. When I'm selecting one thing from out of four different thing, I can do this in 4C1 way. When I'm selecting two different thing out of four different thing, I can do it this in 4C2 ways. So when I am, so that is the question, what it is saying: total number of selections of zero or more thing out of n different things. So that can be given in how many ways? 2 to the power n ways. How many ways? 2 to the power n ways. Okay, and the number of selection of one or more things out of n different things. Okay, see, now when we are selecting zero things, then we can do this in zero ways. Okay, one way. Okay, selecting zero thing is also a way, so that we are including as one way. That is given by 2 to the power n. But when you are not including the zero selection term, that you have to select at least one thing or more things, so that can be done in 2 to the power n minus 1 way. Why? Because nc0 is 1. Okay, so when this will be eliminated, you can now select either one thing or n things out of n different things. So that can be done in nc1 plus nc2 and dot 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 ncn ways. So that can be done in 2 to the power n minus 1 ways. Okay, 2 to the power n minus 1 ways. So this is how we do these kind of questions. Now let's move forward. Now look at this: number of ways of distributing n identical things among r person when each person may get any number of things. Okay, number of ways of distributing n identical things, number of ways of distributing n identical things among r persons when each person may get any number of things. Okay, so that can be done in n plus r minus c r minus 1 way. So see, basically what I am trying to tell you here, try to understand this with the help of an example. So we have 27 marbles and we have to distribute in 4 people. Okay, so that each person may get any number of thing. Okay, each person may get any number of thing. That is, see, I have 27 marbles, so I have to distribute among 4 different people. Okay. And see, each person may get any number of things. So either he can get 0 marble also, or 27 marble also, or any other term also. Okay. So how many ways I can do this? So that is given by n plus r minus 1 c r minus 1. Okay. That is given by n plus r minus 1 c r minus 1. So how many identical marbles I am having? 27 identical marbles I am having. N identical things I am saying? No. So I have 27 identical marbles. I have to distribute among them four people. Four people. Okay. So, and in how many ways I can do that? So that will be given by n plus r minus 1 cr minus 1. So what is n here? 27. What is r here? 4 minus 1. So this will become 30, and this will become 4 minus 1. So 33 c 30. 30 c3. Okay. So that is given by what? That is given by this thing. Okay. So I hope now you are clear with this thing. So that you have n identical things, you distribute among r people. So how many ways you can do this? N plus r minus 1, c r minus 1. Okay. N plus r minus 1, c r minus 1. I hope everybody is clear with this thing. Okay. Now, look at this concept. Number of ways of dividing n non-distinct things to r distinct groups. Okay, now we have groups. Okay, so that can be done in how many ways? See, we have n non-distinct things. So means we have n identical things to r distinct groups. So we have to distribute this in r distinct group, and for non-empty only. They should be non-empty group, that we have to give something to each group. Okay, so that can be done in n minus 1 c r minus 1 way. Okay. Also, the number of ways in which we in n distinct thing can be distributed to r different person. Okay. So we are given n distinct thing, and we have to distribute it to, let's say, three people. है ना? So we have like that four rings we had. Okay. And we had to distribute it to three fingers. In how many ways we did that? Okay. We did 3 to the power 4 ways. So three fingers were distinct. Rings were identical. You did in 3 to the power. Sorry, rings were not identical. It was not said that. And distinct things can be distributed to our different people. So 3 to the power 4 ways. Okay. So we had like four distinct items. We have to give to three people. So we did in how many ways? 3 to the power 4 ways. Okay. 3 to the power 4 ways. So I hope this is very clear to you. Very little concepts are left over now, so we'll do this in next class, and we'll do a lot of questions for 3 4 classes, and I hope this is very clear to you all. Okay, so let us meet in the next class.